Good morning, friends. Today we shall discuss about the formation of the P N Junction diode as well as depletion region, internal potential barrier, how it is formed, and we shall also discuss the working of P N Junction diode in forward biasing and reverse biasing mode. So first we shall discuss about the formation of P N Junction diode. Now P N Junction diode is formed by using p-type semiconductor as well as n-type semiconductor. Now first we shall discuss about the p-type semiconductor. The semiconductor in which holes are majority carriers is called as p-type semiconductor. N-type semiconductor means a semiconductor in which electrons are majority carriers is called as n-type semiconductor. Now the behavior of semiconductor is in between insulator and conductor. It is neither conductor nor insulator, it is semiconductor. Means it is half conductor, half insulator. Okay. Now in the p-type semiconductor there are holes which are majority carriers and electrons are minority carriers. In n-type semiconductor there are electrons are minority carriers and holes are majority carriers. Now minority and majority carriers means suppose there are 100 holes in the p-type semiconductor, then there will be 10 electrons. So holes are large in number, electrons are small in number. Therefore holes are majority carriers and electrons are minority carriers. So it is all about the majority carriers as well as minority carriers. Now when a PN junction diode is formed, then electrons in the N region and holes in the P region near the junction recombine with each other, and therefore they vanish or they destroy. So special area is formed near the junction in which there are no mobile charges, no mobile electrons or holes, only ions are present. That area is called as depletion region. So we know in the P region there are negative ions, they are called as acceptors. In N region there are positive ions, they are called as donors. Acceptor means they accept electrons, therefore they possess negative charge. Donors means they donate electrons, therefore they possess positive charge. So the special area is formed near the junction in which electrons and holes, that is mobile carriers, are absent, only ions are present. It is called as depletion region. Now when depletion region is formed, then a special voltage is formed that is called as internal potential barrier, whose value is 0.7 volt for silicon diode and 0.3 volt for germanium diode. So it is all about the formation of PN junction diode. So we know when PN junction diode is formed, then two things are formed. One is depletion region and second is internal potential barrier. This internal potential barrier prevents further recombination of the electrons and holes. Okay. Now we shall discuss about the working of PN junction diode in forward biasing and reverse biasing mode. Now biasing means, what is biasing? Biasing is application of the voltage. Now we apply the voltage to PN junction diode in two ways. One is forward biasing and second is reverse biasing. Now when we apply DC voltage, we know DC voltage have two polarities, positive as well as negative polarity. When positive polarity of the DC voltage is directly connected to the P region and negative polarity of DC voltage is directly connected to the N region, that is called as forward biasing. Now when PN junction diode is forward bias, then it offers very low resistance to the flow of current. Therefore current through PN junction diode is large. When PN junction diode is reverse biased, it offers very high resistance to the flow of current, and therefore current through PN junction diode is very small. So first we shall discuss about the working of PN junction diode in forward biasing mode. When positive of the voltage DC voltage supply is connected to the P region and negative of the DC voltage supply is connected to the N region, then due to positive polarity, holes in the P region diffuse junction enters N region and recombine with equal number of electrons in the N region. At the same time, due to negative polarity of the battery, electrons in the N region diffuse junction and enters P region and they recombine with equal number of holes in the P region. So in the P region there will be loss of holes, as well as in the N region there will be loss of electrons. Both in P region and N region, loss of holes and electrons will be equal. Means if we say 100 holes lost in the P region, then same holes will be lost in the N region. So this loss can be overcome by breaking covalent bond in the P region and by supplying equal number of electrons to the N region. Now loss of holes in the P region is overcome by breaking covalent bond, and we know, suppose there is loss of 100 holes in the P region, then this loss can be overcome by breaking 50 covalent bonds, and we know each covalent bond consists of 2 electrons and 2 holes. Therefore when 50 covalent bond breaks in the P region, then 100 holes and 100 electrons are formed. So in this way loss of 100 holes can be overcome. The remaining 100 electrons will flow towards N region through DC supply voltage. Okay. So in this way loss of electrons in the N region also overcome by supplying equal number of electrons to the N region. So in this case, in this process, electrons and holes flow in the P N junction diode, hence current flow due to them. But in the outside circuit, in the wire, only electrons flow from P region through battery to N region. Therefore current flow due to flow of these electrons in opposite direction. Opposite direction means in clockwise direction. That current is called as forward current. So when the P N junction diode is forward bias, then forward current flow in the P N junction diode due to majority carriers, that is holes in the P region and electrons in the N region. But in the outside circuit only electrons are flow, therefore current flow due to only electrons. Now we shall discuss about the working of P N junction diode in reverse biasing mode. Now reverse biasing means, reverse means opposite. Opposite means if we connect negative of the supply voltage to P region and positive of the supply voltage to N region, it is called as reverse biasing of P N junction diode. Now when P N junction diode is reverse bias, the electrons and holes flow away from the junction, and therefore width of the depletion region increase. But we know therefore in this case forward current is 0, because there is no crossing of junction of the majority carriers, that is holes in the P region, electrons in the N region. But we know in the P region there are minority carriers which are electrons. In N region there are holes as minority carriers. For this minority carriers, the applied voltage became forward bias, and therefore they minority carriers cross a junction, that is electrons in the P region enters N region, holes in the N region enters P region. Due to this crossing of the minority carriers through junction, a current flow which is very small in amount, that is called as reverse current. So when the P N junction diode is reverse bias, then reverse current flow in the P N junction diode due to only minority carriers. Since minority carriers are small in number, the reverse current flow also is small in number. It is actually in microampere. Now when we increase reverse voltage, the reverse current doesn't increase, it remains constant, because number of electrons and holes doesn't increase. But when we increase temperature of junction, then due to formation, due to breaking of covalent bonds, electrons and holes in the junction increase, and therefore this reverse current increase when the temperature of the junction increase, because electrons in the bond gains energy and they became free from the bond, and therefore bond breaks, and therefore electrons and holes increase in the junction, and therefore reverse current also increase. So mainly reverse current depends on the temperature, not on this applied reverse voltage. So it is all about the working of the P N junction diode in reverse bias mode. I think you follow it. If you go through books, you can see the figures. I am explaining this topic without any drawing any figure. So if you see the figure in the books and if you listen my video, then you can easily understand. Please subscribe my channel, like my video and share it among your friends. Thanks very much.